So our next chapter is sulfuric acid, which is also known as the king of all acids because of its variety of uses in a lot of methods and processes. So we are going to learn about the manufacture of sulfuric acid on a large scale basis. This process is also known as contact process. Over the last 3 chapters we have learned a lot of names of different processes like Ostwald process, Bosch's process and all. So which process is for the production of which substance, you have to remember that. So in case of sulfuric acid, there is no laboratory preparation. Generally, it is prepared on a large scale only. So what are the methods or what are the steps involved? Let's see. The first step is the production of sulfur dioxide. So the second reaction is important here. Sulfur plus oxygen, it gives sulfur dioxide. So first we will form sulfur dioxide and then the subsequent steps. Next is the purification of the gases. This sulfur dioxide has to be purified nicely so that the process can go on effortlessly. So there are 3 devices through which it is passed so that the impurities are removed. First of all, it is passed through an electric precipitator which will remove the solid particles. Then it will be passed through a water scrubber which will remove the dust particles. Next, the sulfur dioxide will be passed through an arsenic purifier which will remove arsenic oxide. Very important. I guess you have studied about electric precipitator and scrubber in geography. Arsenic purifier is a new thing. After that, what happens? Sulfur dioxide is oxidized. Sulfur dioxide will be converted to sulfur trioxide, but this is done in the presence of a catalyst called vanadium pentoxide V2O5 and at a temperature of 450 degrees Celsius. This is a reversible reaction and the tower or the place where this is done is known as contact tower. So after this reaction is very exothermic in nature. So initially we have to heat and then it will go on without any external heat. Next, the sulfur trioxide is not directly mixed with water and sulfuric acid is produced. Rather, it is first converted into another acid which is known as oleum, and then that oleum is used to form sulfuric acid. Absorption of sulfur trioxide in sulfuric acid. So what happens? This sulfur trioxide is added to H2SO4, small amounts of H2SO4, and we get oleum or pyrosulfuric acid, H2S2O7. Very important. This reaction is very important. This process is done in the absorption tower. So this oleum now is treated with water. H2S2O7 is added to water and we get H2SO4. We are getting acid, our required acid. So why sulfur trioxide is not used directly? Because sulfur trioxide doesn't dissolve in water very nicely. So it will form like a mist. It will not form the required acid in good amount, and also the reaction is exothermic in nature, so it is not feasible also, it is not useful. Therefore we first convert sulfur trioxide into oleum and then that oleum is used to produce sulfuric acid. What are the conditions which are necessary for these reactions? Since it is an exothermic reaction, so initially you don't have to apply a lot of heat. If you apply a small amount of heat, it will be enough. As soon as the reactants are heated, they will produce so much heat in the process that you don't have to heat from outside. Also, a high pressure is essential in this case also. Excessive oxygen has to be there so that sulfur trioxide is formed in large amount. A catalyst has to be there so that the procedure becomes a little quicker. So we use vanadium pentoxide. And why do we remove that arsenic oxide? Because it will act as a catalytic poison. Therefore, purification of the gases are very important. So here we have a summary of the entire contact process. Let me read it out for you. Initially formation of sulfur dioxide happens. S plus O2 gives SO2. Sulfur plus oxygen gives sulfur dioxide. This sulfur dioxide is purified first of all, and then it is converted to sulfur trioxide by using oxygen in the presence of a catalyst vanadium pentoxide at a temperature of 450 degrees Celsius. Platinum can also be used as a catalyst, but since it is costly, it is not used. Next, this sulfur trioxide is converted to oleum or pyrosulfuric acid. SO3 plus H2SO4 gives H2S2O7. Now this H2S2O7 is treated with water and we get our desired sulfuric acid. So below are some common reactions of sulfuric acid which we have also done in the chapter hydrogen chloride. So when sulfuric acid reacts with a metal, it will form salt and hydrogen gas will be evolved. Similarly, with carbonates and bicarbonates, carbon dioxide gas will be evolved along with water and salt. For sulfides, we will get salt, water and sulfur dioxide gas. For sulfides, we are getting salt and hydrogen sulfide gas. And when an acid reacts with a base, we know we get salt and water only. Similarly, when H2SO4 reacts with any OH or any other base, we are getting salt and water only. So the last one is neutralization reaction. Sulfuric acid also acts as an oxidizing agent just like nitric acid, but the reactions are a little different. We will learn it for carbon, sulfur and copper. So carbon, when reacts with sulfuric acid, it will produce carbon dioxide, water and sulfur dioxide. Sulfur, when treated with sulfuric acid, it will give sulfur dioxide and water. Talking about the dehydrating nature of sulfuric acid can remove water from almost everything, be it chemically combined water or be it normal water of crystallization. So all carbohydrates, sugar, glucose, etc., when it is treated with H2SO4, it will give carbon and water. As you can see in the figure on the right hand side, this is the carbon which is formed when sugar is treated with H2SO4. This is also known as sugar charcoal because it is a type of charcoal, or it is a type of carbon which is formed from sugar. So it is a black spongy mass and it is very hot. So this process can also be called as charring. Next, if hydrated copper sulfate CuSO4.5H2O is treated with H2SO4, the sulfuric acid can easily remove the water of crystallization and we get anhydrous copper sulfate. But this anhydrous copper sulfate is not pure white in color, it is a little dirty white. So sulfuric acid acts as a very strong dehydrating agent. It can remove water in chemically combined form also, and also in the form of water of crystallization. The non-volatile nature of the acid is seen when we prepare some other acid from it. We have seen about this property in hydrogen chloride chapter and also in nitric acid chapter. The same reactions, NaCl plus H2SO4 gives NaHSO4 plus HCl, and if we use NaNO3 in place of that, we will get NaHSO4 but HNO3. All these reactions have been written at temperatures less than 200 degrees Celsius. Tests for sulfuric acid and sulfates. So these reactions are very important. Concentrated sulfuric acid on heating with copper evolves sulfur dioxide, and sulfur dioxide will turn acidified potassium dichromate solution green. Only the first reaction is essential. You can skip the second reaction. Only the thing which has been highlighted is okay. So whenever concentrated sulfuric acid is treated with copper, it will evolve sulfur dioxide gas, and that sulfur dioxide gas will change the color of acidified potassium dichromate solution. So if we don't know what acid is present with us, we can do this experiment and understand that if it is sulfuric acid. Also, sulfuric acid on heating with NaCl, it will give pungent fumes, very bad smelling fumes of HCl gas. And HCl gas, you know, if we bring a glass rod dipped in ammonia near HCl, we will get dense white fumes of ammonium chloride. So using this also we can identify the presence of sulfuric acid. Also, when barium chloride BaCl2 is treated with H2SO4 or any other sulfate, metallic sulfate, it will give a precipitate of barium sulfate BaSO4, which is white in color, and this precipitate helps us to identify that this is sulfuric acid or this is sulfate. So these three tests for identifying sulfuric acid are very important. So when sulfur dioxide is treated with orange potassium dichromate, see, it is turning green. So initially it was orange, now it is turning green. These are the white fumes of NH4Cl which is formed when HCl is treated with NH4OH, and this is the white precipitate of barium sulfate which is formed when barium chloride is added to sulfates or sulfuric acid.